Hello everyone, welcome to this presentation. In this presentation, I will tell you how you can transition from software engineering to machine learning. And the main message I want to convey in this presentation that if you're an engineer, you're already qualified to do machine learning. A few words about me. So I work now as a principal data scientist at OLX Group, but I started my career as a Java developer. So 10 years ago, I graduated from my studies and then I joined the company as a Java developer. And then I worked as a Java developer for a couple of years until at some point I came across a course from Coursera called Machine Learning. And that course changed my life. And I understood that this is the thing I want to do. Then I went through masters. Then I joined a company as a full-time data scientist. And I worked at a startup. And now I finally joined OLX, where I work today. And as a data scientist, I need to deal with many different machine learning systems. And this is a typical machine learning system that I need to deal with. This is one of the systems where I took part in when at OLX. And this is our content moderation system. So you see that a lot of things are going on here. So it basically describes the data flow, how like when you create a listing, like when you create something on our platform, like it doesn't really matter. Maybe you don't know much about OLX, but what matters is it's a large, complex system. There are many different things, many different moving parts, and it's just a big system, right? And there is machine learning in this system, but this machine learning is only a small part of that. So there is an automatic moderation system that contains some machine learning, but all the work around it and actually work inside this automatic moderation system is mostly engineering work. Yes, we have some models, but to be able to use these models, we need to write a lot of code, and it's all engineering work. In fact, this is a well-known fact. There is a paper from Google called Hidden Technical Depth in Machine Learning Systems. And this is quite a famous picture from that paper from Google that shows that the core in a machine learning system, the core with the actual machine learning is very small. And the rest, like all the rest, is infrastructure and engineering stuff that has little to do with the actual model, right? So there is a lot of engineering work that needs to happen for a machine learning model to be successful. And what I can say, what I want to say with this, the message I want to send is you as an engineer, you already know how to do all this stuff. You already know how to do all this stuff as well. What you do not know yet necessarily is this little thing in the middle. So this little ML core thing, this is what you still don't know, right? Or maybe you're already starting exploring this, but this is the thing you need to cover. And the rest, you already have 90% of the required skills to be successful as a machine learning engineer or as a data scientist. You only need to fill this 10%, and then you'll be qualified to do machine learning work. To actually to learn this remaining 10%, I want to suggest a learning plan. So in the learning plan, you need to start with fundamentals. So you really need to focus on the most impactful models. And these are usually simple models. So this is actually the second step. So these are the models like linear regression, logistic regression, tree-based models. And then you also need to learn how to evaluate your models. Once you do this, you learn how to deploy your models. And by deploying, I mean, you take a model you trained and now you need to put it inside a web service, for example, and then serve your model such that the customers, the clients of your service can use it to make business impact. And only after that, you learn more complex things like neural networks and so on. And this is also the plan of the presentation today, because I want to show you how you can learn these things. And the easiest way of doing this is by doing projects. So as a software engineer, for me, this is the easiest way to learn things. So I focus on a project, on a problem of a particular project. So, and instead of going deep in theory, reading a lot of books, I just focus on doing the thing that, focus on building. So let's start with fundamentals. So actually, even before doing any machine learning work, we need to learn some tools. In machine learning, currently, the Python is the lingua franca of the machine learning world. So if you are serious about this, you have to learn Python. Of course, you can do it with some other languages, but yeah, most of the libraries, they are implemented in Python. So you'll be better learning Python. Then once you do this, you just need basics like how to write a for loop and things like this. Then you learn NumPy. NumPy is a library for matrix. It's a library for numerical processing, including matrix multiplication and things like this. But this is basically like things for dealing with numbers. And then finally, you have pandas, which gives you a nice data frame, data structure, data frame. So you have sort of Excel-like feeling. So you have tables, you have columns in these tables, you have rows, and so on. So you focus on that first. And only then you go with machine learning. And now I want to show you something scary. So this is something that all software engineers are afraid of. And let me show you what it is. It's a mathematical formula. It is scary, especially if maybe you learned some mathematics at college, but yeah, maybe the teacher was mean or something like this, or like maybe it was cool and you really enjoyed this, but it was so long ago that you simply forgot. So, and when you're trying to learn machine learning for the first time, it's scary, right? So you're used to seeing code and now you have a formula and now you need to understand what's going on in this formula. And what I want to suggest you, so this is, I think this is the #1 blocker for software engineers to get into machine learning, is they see a formula and now they get scared. And the way to overcome this is to see at this, actually, this is a bunch of matrix multiplications. So there are a bunch of matrix operations. So I want you to see at this not as a mathematical formula with symbols that look scary, but as a bunch of different code. Right? So here we have matrix multiplication, and matrix multiplication is nothing else but a bunch of for loops. You can implement matrix multiplication with real for loops. So you can do that. And once you do this, you can immediately translate this formula into a sequence of into code, and then it becomes less scary. So this is what worked. This is what worked for me. And I think this is what will work for you. And so this is something you can do at home. So after watching this, so you take a look at vector-vector multiplication, matrix-vector multiplication, matrix-matrix multiplication, and you try to implement them with a for loop. So with multiple for loops. So just let's say if you're new to Python, open Python, download Python, open Python, and then try to implement these operations yourself. And then you will see that this is not scary. And as I said, the best way of learning things is by actually building things. So one thing you just saw, I suggested you to learn matrix multiplication by implementing this. But of course, you can do much, much, much more. And I want to suggest a couple of projects. So I want to suggest 4 projects that you can do to become good at machine learning. So to learn the 20% of the machine learning that you need to cover 80% of the cases. So I want to suggest 4 projects. And the first project I want to suggest is building a car price prediction service. So imagine you have a website for selling cars, right? And you want to help sellers on this website to come up with good prices. So let's say if you want to sell a car, you go to this website, you fill in some details. So you say, I want to sell a BMW of this model, like with this mileage and so on. And then it just gives you a recommendation. This is how much you should sell it for, right? There is available data for that, so you can find available data with car characteristics and prices, and then you can build a model for that. Actually, the small disclaimer, these projects, I didn't mention that I wrote a book about machine learning, and the projects I'm talking about now are from this book. And you don't have to buy the book, but all the code from the book is available. So if you're interested, let's say, to see how it can be implemented, there is a link that you can just, there is a GitHub repo with all the code that you can just use to check how these things can be implemented. But actually, I encourage you to find out how to do this on your own. So you will learn a lot by doing this, by looking up different things and then trying to collect the data, trying to see what kind of things you need to use, and then finally solving. So then, of course, this way you will learn much, much better. So the first project that you can build is for predicting the price of a car. Then, and this in machine learning, these problems of these types are called, regression. So you want to predict a price, some number. But there are different problems when you want to predict some binary outcome. So in this case, let's say you're a company and you have different clients, and some of these clients decide to leave your company. So this is called churn. So people decide to cancel the contract. And the outcome here we want to predict is binary. So either person churned or they didn't churn. So churn, so this is binary: 1, they churned; 0, they didn't churn. This type of problems in machine learning is called classification. And you can now use a different family of models, of machine learning models, to solve a problem like that. So now you build, there is available data for that as well. So, and you can also take a look at the code that I include here. There is data from a telecom company with information which users churned and which didn't. So you can take that and build another model which predicts the binary outcome. So it will score all the customers we have and assign a score for them between 0 and 1, 0 meaning they are not going to churn, 1 meaning that they are going to churn. So you can build a model like that. And here, the important thing is, it's not enough just to build a model. You need to be able to evaluate this model. So there are different things that, like, okay, accuracy, for example, precision, recall, all these things. It's quite important to understand that. So as a software engineer, you really need to learn this. And this might be quite a tough topic. So this is conceptually, it needs some time to actually remember these concepts. This is an important topic. So you need to really understand how you can evaluate the quality of your model. So you build this churn model. Now, can you tell others how good it is? Like, what is the accuracy of this model? What is precision? What is recall? And things like this. So you need to be able to understand the terms and then report these terms to others to say how good your model is. So this is something you also need to cover. And then this is something that is equally important, even more important. I think this is like the most important part of machine learning is once you have a model, let's say this churn model, now you need to deploy it. And typically what this means is you take a model that you trained and you put this inside a web service. And then the clients of your web service, the clients of your service can just send you some requests and then get responses. This is for you as software engineers. This is this shouldn't be difficult. This is probably what you're doing already every day. Like, this is typical web development, except you add a model inside your web server. But this is the most important part. So if you don't have that, then there is no way for others to use your model. Right? Well, it's not, of course, the only way of serving models. There are different ways. So you don't always do it through a web service. But yeah, you need, your clients need to be able to use this model, and you need to let them do this somehow. That's why this is the most important thing. And you as software engineers, you already know how to do this. So you just need to see how this is usually done in machine learning, but you really need to take advantage of your engineering skills because they are very, very important for machine learning. So you do this for your project, you deploy it. And with this, you kind of close the loop. So you train your model and you deploy it. So now you have a complete project that covers quite a few steps of in machine learning pipeline, in machine learning project pipeline. So then the next project you can do is you can build a risk scoring model. So imagine a scenario that you want to buy something like a car or a mobile phone. And then you go to some financial institution, let's say a bank, and then you ask the bank, can I have some money? And then the bank thinks, okay, but let me see. And then they ask you some information like, have you had problems with paying back loans previously? How much money you have? How much like total assets? And things like this. And then they run all this information through this risk scoring system. And then they can say, okay, here you go, here is your money, or we don't want to give you the money, right? So they typically, many banks use machine learning for that. And this is what you can also do for that. So you can get a data set for that. You can build another model. So this is again a classification model. So you want to predict if customers are going to default or not. And default meaning they will not be able to pay back the loan. So you can find a data set, credit risk scoring data set, and here the target variable, it's again a binary classification problem. 1 means default, 0 means not default, like well, good. And now you build a model and you go through the entire life cycle again. So you not just build a model, you also put this in a web service. So this is your third project. And by this time, you probably have, it's already a good portfolio, like when you have 3 projects and you can explain what's going on in these projects, but you can add another project. So before we talked about simpler models, and it's important, really important to start with simpler stuff. But at some point, you also probably would like to try something more complex. And there you can take something like previously we just worked with simpler data sets, but you can try to do image classification. So for example, in this case, so this is just like a schematic of a neural network. So there is a good library for that called Keras. So this is what you can use for building your neural network. And the problem that you can solve is you can take a data set with images of clothes and then predict what kind of clothes or what kind of type of the clothes it is. Well, for example, if you have an image of a t-shirt, what kind of t-shirt is, what kind of clothes is it? Is it a t-shirt? And if it's an image of, I don't know, hat, you want the model to output hat. And so there is a data set for that with different types of clothes, and you can build a model for predicting that. It's more complex. So there are neural nets are more complex models than other models, but yeah, by now, by the 4th project, you already have enough experience to understand what's going on. And yeah, once you have that, you should also go ahead and deploy this model. And what you can do is you can deploy it using some cloud solution. So for example, using AWS Lambda. So with deep learning, serving models through AWS Lambda is a bit tricky. So that's why it's worth putting some effort and learning how to do this. And this is what you can do as a project, as a part of your 4 project. And then if you don't know Kubernetes, I think you should learn. But I think my bet, you as a software engineer probably know it and use it. So what you can do also as a part of this project is take the model we just built, right? This clothes classification model, and put it inside, like deploy it with Kubernetes. right? And then like if you already use Kubernetes, if you have used Kubernetes, then for you, it will not be super difficult. If you haven't, you will learn a lot, and this will be a super valuable skill. So once you have these 4 projects and you can put them to your portfolio, and then you'll have a really great portfolio. I am sure that if you can explain all the steps in these projects, every hiring manager will be happy to get you in their teams. But of course, it doesn't stop there. So you can learn a lot more. So you can, the best way for me personally of learning data science was doing data science competitions. So there are many different websites for that. One of them is Kaggle. So I do recommend checking it out. Then build end-to-end projects. So Kaggle is good because the data set is already there. The projects I suggested, they are also good because the data sets are already there, prepared, but try to do your own end-to-end project. And by end-to-end, I mean, not just take a data set that somebody has prepared, but build your own data set and then train your model on top of this data set and then deploy this model. And this is what I mean by end-to-end, when you have the entire when you cover the entire life cycle of your project, from data collection to model deployment. And finally, you don't have to do this alone. There are many different communities where you can ask for help. And as it happens, I run one of such communities, DataTalks.Club. This is a place where data enthusiasts can hang out together. So if you're serious about learning and you want to find somebody who you want to learn with, or you want to find somebody who you can ask questions, join DataTalks.Club. This is an amazing data community. So we have Slack, we have weekly events, we also have courses. And by the way, one of the courses, it's already running. So we are on week 10. But if you're interested, you can watch the recording that we have and maybe take it at your own pace. And that's it for the talk. So the main message I want to convey is, you as a software engineer, you already have 80% of the required skills. You need to start with fundamentals. Here it's Python, NumPy, and Pandas. And then you don't need to be afraid of math. You need to realize that it's nothing else but a bunch of for loops. And what helps here to convince yourself that this is the case is actually trying to convert the formulas you see into the code. And learning by doing, learning by building is the best way of learning, in my experience. At least this is, I think this is pretty common for software engineers. So you can learn a lot by coming up with a problem and then finding solution to this problem, instead of just, going through textbooks and trying to study everything that is there. So focus on the problems. And then there are 2 things that are quite important that you need to learn well. The first one is evaluation. I talked about this, like things like precision recall, that will probably require a bit more effort from your side because they're more abstract things. But yeah, this is something really worth investing time into. And then deployment for you will be easy, but this is a very important step in machine learning process. And then finally, don't do this alone and join a community. That's it from my side. If you have any questions, I'm happy to answer. You can find me on LinkedIn, on Twitter, and also in DataTalks.Club. That's all. Thanks for your attention and see you soon. Goodbye.